All right. Hi, everyone. My name is Caleb Hellmund, and I am a undergraduate student at Liberty University. And today I'll be presenting on research done under Dr. Wayne Strasser and Rob Kalinsky on local hardware benchmarking in comparison to cloud computing. But to begin with, why bother with local hardware when there are so many benefits to cloud computing? Some of those include scalability. It's much easier to scale on a day-to-day basis with cloud computing versus local hardware, in the sense that if you need to increase your compute hours at any given time, it's much easier to do that with cloud computing than to buy more hardware. And on the inverse, it's easier to decrease than just have your hardware basically being wasted as you're not using it. It's also just easier to access, and it doesn't take the same upfront costs and technical skills required to set it up and maintain. So in a lot of ways, cloud computing is much easier, but all of those benefits would come with some costs. And what we were experimenting with was that we were paying much more money for much less computing power. And that's what we wanted to test with this research. So to do that, we took 4 different computing setups, 3 at our lab, 3 on-premise systems, and then 1 cloud computing. We benchmarked 6 different computational fluid dynamic simulations, 3 different models, each with a large and smaller counterpart. And we ran a total of about 1,000 different simulations. The hardware we used, the first one was a Bison X6000. It had dual AMD EPYC processors, a total of 384 single-thread cores, and this system cost about $53,000 as of April 2025. The second system used was a Titan A900 Octane. It had dual EPYC Turin processors. It had 128 single-thread processors and cost about $27,000 as of April 2025. And the third system was actually a cluster of 10 CyberPower PCs, each with a Ryzen processor. They each had 16 cores, and each cost about $2,500. And with the entire setup, it cost about $31,000 as of April 2025. And all of those were compared to the Rosinite, a cloud solution from Azar, which had an AMD EPYC processor. We had access to 120 cores, and this system cost $42,000 per year instead of a single cost. We chose this one based on previous research, and this was just our most economical and overall best cloud solution that we had experimented with. Before testing, we did optimize the local hardware. We tested different Fluent versions and found that the 2023 version performed better than 2024. We optimized for cores per node. Previous research found that just increasing cores per node doesn't always make the system run faster. So we did optimize for that and tested the 3 different MPI settings that Fluent offers and found that Open MPI, that setting was the fastest. So with that, our test included a coarse and fine atomization with 8.8 million cells and 132 million cells, a coarse and fine direct numerical simulations, or DNS, of 8.4 and 66.6 million cells, and a coarse and fine sliding mesh reactor of 5.8 and 55.3 million cells. The procedure we used, we ran this all with a Python script. It generated a machine file to specify which nodes and how many that Fluent would use. It would then use that file to launch Fluent, and before benchmarking would run 20 time steps at 10 iterations to reduce variability or variety in our results, just to get more consistent results. And then it would actually run the benchmark at 60 time steps and 10 iterations per time step. Our results, here's a graph for all of the course models. Important note that the y-axis is the runtime. So the lower the y-axis, or lower on the y-axis, the faster it ran. And this was normalized for the slowest. So 1 is the highest you'll have. You can see up here that Rosinite is running the slowest on the models that we tested, with our local hardware performing much lower. And then over here on the right, we actually have the Bison, which had the substantially more cores running even faster. And that's for the course model. You can see the line at the bottom. It just highlights the fastest run per node count. And then for fine models, we had very similar results. Again, normalized for the slowest results, and the y-axis is time. Once again, the cloud solution was much slower, and however this time our Bison didn't run quite as quickly on the fine models, and the CyberPower cluster actually ran faster due to the fact that while it had fewer cores, these cores are actually faster than the Bison. So with that, we have here's a table with all of our results, and this is a ratio of the performance of the local hardware over the performance of the cloud computer. So if the value is 1, that means that both solutions ran equally as well, while having a value greater than 1 means that the local hardware ran faster. So you can see over here that the Bison ran the fastest on the coarse models, while the CyberPower PCs ran the fastest on the fine models. Also wanted to point out that we ran a cluster with 5 CyberPower PCs, which ran almost equally with the cloud computing, and we also tried 1, but that one ran much slower. So our conclusion, just a reminder, the Rosinite that we were comparing with cost $42,000 a year. The Bison, which cost $53,000, a one-time cost, ran twice as fast as the Rosinite on the course models, and the 10 CyberPower PCs ran roughly 2.3 times faster on fine models. And we even had the cluster of 5 PCs, which was running equivalent to Rosinite for only a one-time cost of $18,000. So in short, we were paying much more money for much less computing power. So just to wrap everything up, we ran 6 different CFD simulations, 3 different models with a large and small counterpart, 4 different computing setups, 3 of them local and 1 of them the cloud. And we found that the local hardware provided much better value than the cloud solution did. And with that, I'm going to open it up for any questions. Thank you.
Right, thank you. Any question?
Yes.
So I just have a question, like how do we know that this is going to perform at the same level year round, and then the second year, then the third year? Because we know cloud will perform at the same speed, like theoretically throughout its lifetime. So how do we quantify that?
Yeah, that research wasn't done, so I wouldn't know.
Okay. Did you consider the electricity cost?
That was not calculated. So this was just the one-time cost. There would be recurring costs for maintenance and electricity.
That's fine. Very interesting. Any other questions? All right. Let's thank our
Thank you.
speaker.